this is 8086 instruction set. So in this instruction set, the instructions are classified based upon its functionalities. So as the name suggests, data transfer instructions are used to perform transferring of data, okay, from one place to another. You can get the data from the input, transfer it to the output, or get the data from the output, transfer it to the input, or transfer the data within the memory, okay, or within the registers somewhere. But I'll transfer a data, collect a data, or give a data, okay. Collecting the information and transferring the information is data transfer, okay. So those kind of instructions comes under data transfer instructions. The second comes the arithmetic instructions. So the instructions which are used to perform arithmetic operations, addition, subtraction, multiplication, division, increment, decrement. So all these are arithmetic instructions, okay. Then comes the logical instructions. So the instructions which are used to perform logical operations, as you have studied in your digital electronics, the logical operations are and, or, uh, nor, NAND, not, inversion, okay, complement, okay. So all those are logical instructions. Then the type of instructions which can perform bit manipulation. Bit manipulation means here 8086 is a 16-bit processor. So in that 16-bit data, I can operate on a single bit. If I want the 8th bit alone to be changed from 1 to 0 or 0 to 1, I can set that bit alone or change that bit alone, okay, from 1 to 0 or 0 to 1. If I can this individual bits in a data in a word, then it is called as bit manipulation instruction. For example, rotate instruction, shift instructions. So all these instructions are used to shift one bit, okay. So if I say shift left, then this data will be shifted to the left bit, this data will be shifted to the next bit, this data will be shifted to the next bit. So this is how shifting of individual bits will happen, okay. So these are examples of bit manipulation instructions, okay. So what is the necessity of bit manipulation instructions is a lot of applications are available. If you have to multiply, just shifting a data or rotating a data will make it multiply twice, okay. I'll give a small example. If you take a 4-digit number, okay, 4-bit data, 0100. So 0100, the value is, decimal value is 2, okay. Now I am shifting it left. What will happen? 0010. So now what is the value? The value is 4. So what happened? From 2 it became 4, okay. Now again shifting it one more time, 0001, okay. So 1000. So if it is 0010, it is 2. 0100, it is 4. 1000, then it is 8. So what happens? By shifting only one bit in a fraction of microseconds, I can multiply, I can double it, right? Similarly, if I shift this side, what will happen? 10008. If I shift it on right hand side, it will become 0100. It will reduce to half, 4, okay. 0100 is 4. Similarly, if I shift to right again, so 0010, it will become 2. Divide by 2, okay. Again if I shift, it will become 1, right? 2 by 2 is 1. So I can reduce it by half. So I can do multiplication, I can do division in a fraction of microseconds just by shifting a bit, okay. So these are the applications, just a small example to make you understand. These are the applications of bit manipulation instruction. So like this you can use it for other purpose also, okay. So next comes the branching instructions. So branching instructions are used for transferring the program control to from one location to the other location, okay. So while writing a program, when you want a loop, so you are transferring the control. So those kind of instructions, jump instructions, loop instructions, all these are examples for branching instructions, okay. What is the difference between branching instructions and subroutine instructions? So So both are similar. That is why they have grouped those two signals here. Okay, so logical instructions and bit manipulation instructions are similar but not same. So logical instructions also performs on bitwise operation. Okay, so if I want to do AND operation, then what it will do? It will take first 2 bits. I have two 8-bit data or two 16-bit data. First bit of this first input, first bit of second input. Those two data will be taken as input and perform AND operation. Then second inputs, second bits AND operation, third bits AND operation, fourth bit AND operation. So like this, it will do for all the 16-bit data. Then it will get the result. So here also, actually, what is happening? It is performing bitwise. Okay, but you cannot change an individual bit value. That is the difference between logical instruction and bit manipulation instruction. For bit manipulation instruction, only one input. For that one input, you can change individual bit. Okay, logical instruction, it performs AND operation between two datas. It performs OR operation between two datas. Okay, not is only for one data, one input data, but it performs for a whole 16-bit data. Okay, you cannot perform for an individual bit. That is the difference between logical instruction and bit manipulation instruction. They are similar but not same. Similarly, branching instructions and subroutine and interrupt instructions are similar but not same. The difference is branching instructions used to transfer the program control within a program. You can jump within a program. You can use loop until the value becomes 0. You can make it work again and again. Iterations. You can make the program to run in iterations, any number of iterations based on a logic, based upon a value by cross-checking any inputs. You can repeat these iterations within a program. That is the example for branching instruction. If you want to transfer the control from one program to another program, then it is called as subroutine. Okay, so call another program is an example for call instruction is an example for subroutine. Okay, similarly, when you jump from a main program to a subroutine, after completing the task, it has to return back. Okay, so after returning back, for returning back to the main program, I should have an instruction in this subroutine. So that instruction is return instruction. So RET, return instruction will return back the control to the main program. So call will transfer the control from main program to the subroutine. Return will transfer the control from subroutine to the main program. So these are examples for subroutine instruction. This is also branching, but not within a single program, from one program to the another program. Okay, so this is the example for subroutine instructions. So this also looks similar to branching instruction, but slightly different. Okay, similarly, interrupt instructions are also similar to branching instruction, because when I provide an interrupt, what happens? This program which is being running, if a main program is running, if I provide an interrupt in between, that program has to stop where I generate an interrupt. So it will stop there, and it will transfer the control to the place from where interrupt has been raised. If a device is raising an interrupt, IO device is raising an interrupt, the control will be transferred to the IO device. If the memory is raising an interrupt, control will be transferred to that memory station. Okay, so here also my program is stopped, transfer the control to the place from where interrupt has occurred. Okay, then after that interrupt is being solved, it comes back to its main program and starts running. One simple and best example that you are doing using daily is if you are using your laptops. Okay, so if you are watching a movie or listening to a music, a program is running. Okay, so the video is being displayed. You press the pause button. Okay, then you minimize it, go to the other place, open another program, a Word document, a PowerPoint presentation, Google or mail, or do something. Okay, type there, work there. After completing it, you come back and then again you start playing. So this program has been interrupted, stopped in between, and it starts resuming from the place up, not from the beginning, right? So this is an example for interrupt instruction. I'll give you in the mobile phone. In mobile phone also, interrupt is used many times, every time you use your mobile phone. Okay, let me give an example. So for example, if you are listening to this, if you are listening to this class, Okay, you have opened Zoom. Okay, what you are doing is you are minimizing it, going to home, pressing the home button. You are minimizing the Zoom. Your home screen will be displayed. All your apps will be displayed. Okay, this program is running at the background. Here you are using your microphone as well as speaker to attend this class. You want to answer me, you unmute, you connect the microphone. So your microphone is used by this program right now. Zoom is using your microphone as well as your speaker. Okay, suppose now if you are getting a call in between, what will happen? When a call is being received while your program is running, only one program can handle the speaker and mic at a time. Okay, so if you transfer the control from your Zoom to your call, then you will not be able to listen to this Zoom. Okay, that mic and speaker will be disconnected. Okay, or it will be stopped. Then you can attend the call, you can come back and attend this. Or sometimes, in depending upon the mobile phone, it changes. Okay, sometimes what will happen, when you attend the call, you will attend the call, but you will not be able to speak to the person. That person will not be able to hear you because your microphone is being connected to this program. So your call will not be connected with the microphone, so your voice will not be audible for them. Sometimes their voice will not be audible for you. So that is example for an interrupt instruction. So here the interrupt instructions are working at the background to transfer the control from one program to the other program. After completing the task, it will return back to this program and start executing. So it is also similar to branching instruction, but they are called interrupts because we do not know when it will occur. Okay, it is an emergency situation. For example, when you are listening to this class, if you get a call, you will never know whether you will get a call or not. So during that period, your microphone has to be used by that person. So what Zoom will do is Zoom will disconnect and give it to that person. Okay, that program. So the calling device. Okay, so when you attend that, your microphone will be connected there. This here you cannot answer. Okay, so this will be the example for interrupt instruction. So program, while writing a program, you have to use all these kind of instructions. So branching instruction, subroutine instruction, interrupt instruction. All these three types of instructions are similar but not same. So it varies depending upon the usage, place you need. Okay, and then comes the string instance. Okay, so you might have studied about string, a group of characters. Okay, so here they are not considered as values. So you can perform string operations using your 8086 microprocessor. Okay, from that period onwards, it has started evolving. So you need not operate only on the values number system. You can also operate on string values without considering the strings, without considering their actual values. Okay, so without performing data operations. Okay, so those operations are performed using this kind of instruction. Then processor control instructions. So this branching instruction, you might think that this is similar to branching instruction. They said program control is being transferred. Okay, when branching instruction is executed, interrupt instruction is executed, stopped at one place, and then it is jumping to another place. I am linking, looping, or transferring to another place. Okay, that is the job of branching instructions, subroutine instruction, interrupt instruction, all these. Whereas these instructions are processor control instruction. Processor control instruction means it performs operation directly on the hardware. Okay, it changes the functionality of an hardware itself. For example, whatever program you are running on your laptop or PC, take a computer, work on your computer, do any operation. If your laptop is stuck, it has hanged. When you do lots of processing at the same time, no, heavy software, if you run a heavy software, then your software will get stuck, it will get hanged. Okay, when your system is hanging, what is the task that you will do? Either you will press the power button for a long time to reset the system directly. Okay, So what happens here also, when none of the keys are working, the power button key is working. It senses and shuts down. Then again restarts the program. Okay. So what happens? It is resetting my hardware, my controller directly, my processor directly. Okay. So that is a processor control. Okay. So this input makes my processor to understand and it resets itself. Okay. Another example is if you are brilliant, if you know in detail about your system, no, you will not press the power button directly. When your system gets hang, you will use Control Alt Delete. When you press Control Alt Delete, taskbar will be opened. Okay, task manager will be opened. You can select the program which is getting stuck, the software which is getting stuck, and close that program alone. Okay, so here how does this work? Also an interrupt. Actually, this is an it performs operation on the hardware directly. Okay, so these kind of instructions are processor control instructions. Okay, resetting software, resetting your instruction. Okay, so this is how your instruction set is being classified, and only these many type of instructions are available till your i3, i5, i7, whatever processor you are using till date. All these processors, if you go and study about the hardware, okay, so based upon this only they are building, they are evolving. Okay, set. Now your task is, I'll tell you the next thing. So like this, you will have uh, lots of instructions in 8086 for every category of instruction. You can understand from its name. These are the mnemonics. I said no. MOV means move instruction, means input, get the input. Out means transfer the output. Okay. LEA means load effective address. So all this has a meaning, short form. So these short forms are called as mnemonics in assembly language. Okay, so based upon the expansion itself, you can answer. You need not study, mug it up. So these many instructions, you have to know about all the types of instructions based upon the categories. Example: logical instruction, shift and rotate instruction, transfer instruction, branching instruction, subroutine and interrupt instructions, processor control instructions. Okay, so is an example for processor control instruction. No operation, wait operation, escape. Okay, so all these are examples for processor control instructions. Prepare a document. You have to prepare a sheet, all the instructions. Okay, so that is a job I'm going to give you. Each one has to take up any one electronic gadget and draw the block diagram and explain how it is working. So you have to prefer one electronic gadget that uses microprocessor. Okay, so I want you to answer this question, and please do not take the common answers. I want everyone to give a different answer. So mention any one electronic gadget that uses microprocessor. I want you to prepare a block diagram and explain the block diagram. What are the input sensors connected? What are the inputs connected? How it is controlling all the inputs? What is the logic in which it is working? And what are the output devices that are connected? How it is controlled? Okay, so the flow of the workflow of that particular electronic gadget, starting from input to output. Okay, so I have explained in the previous class itself. For any electronic gadget, you can divide that into three parts. One is the input part, the other is the programming part, logical processor part. The third one is the output part. So for input, what are the input sensors used, input devices used, from where it gets the input, when it gets the input, how it gets the input, all the questions. I told you, WH questions. Ask all the questions for the inputs, write the answers. Then after getting that, what process it is doing with input, what with which input, what process, what job, what task it is doing, performing. After that, what kind of output it gives, to which device it gives, how it gives, when it gives. Same, all questions you have to ask for the output. If you answer these two, inputs and outputs, for all the WH questions. Okay, so write these questions itself and write the answers for the inputs, for the outputs. If you write these two, no, you can understand the working of the gadget. Okay, so everyone should have an individual topic and you are going to present it. I want the class to prepare the instruction set. So what you are going to prepare is about all these instructions that I have shown you. Okay, once again I will show you the instructions. So these are the types of instructions: data transfer instruction, arithmetic instruction, logical instruction, bit manipulation instruction, branching instruction, subroutine and interrupt instruction, string instruction, processor control instruction. Okay, so this is your assignment. So prepare examples for all these instructions. Okay, so data transfer means write examples. So in that examples, you will have classification. One is for if you are transferring a data, one is if this is source, this is destination. You will have an instruction to transfer data from this place to this place. Okay, if you want to transfer from here to here, you will have another set of instruction. Okay, so just opposite to that. So like that, in every instruction set, no, you will have different characteristics, different functionalities. Okay, so for every type of operation, I need an example. Okay, for example, in arithmetic, no, addition is a separate operation, subtraction is a separate operation, multiplication is a separate operation, division is a separate operation. Okay, and similarly, increment is there, decrement is there. Increment is an example which is similar to addition. It is also addition, but adding only one. Okay, decrement is similar to subtraction, but subtracting only one. So like that, I want you to give all kinds of examples. Okay, browse, get it from the net, write the examples for all types of instructions, and then post it.